we're going to simplify some more radical expressions here. And I'm starting out with unfactored rationals. So what you have to do is factor them. And remember what you should always check first. First, check for GCFs. Because if you can find GCFs, everything gets easier in factoring. And in this first one, I can see that there is a greatest common factor there of 6. And that leaves behind omega plus 3. And on the bottom, if you factor this one, you'll see that's equal to, let's see, omega plus 6 and omega plus 3. You can use the big X if you want to factor this one. I don't think it's too necessary when the factoring is fairly straightforward, but if you want, go right ahead. And now I can see there's a common factor of omega plus 3, so that cancels out. And you just get 6 over omega plus 6. Now, you might be tempted at this point to cancel out those 6's. Don't do that. That's bad math. You have to remember that you can only cancel out things that are multiplied together. See up here, in this example, those factors of omega plus 3 were multiplied by something. So it was okay to cancel them out. But in this example down here, look at this plus 6. It's not multiplied by anything. It's just plus 6 hanging out. So you cannot cancel it out. Okay, let's move on to this next one. This is going to be, we're going to factor it first. On the top, I have, looks like omega minus 8 and omega minus 1. And on the bottom, we have omega plus 5 and omega minus 1. So those cancel out, and I just get this, omega minus 8 and omega plus 5. And that would be my answer there, okay, in simplified form. It's equivalent to the original expression, it's just now it's simplified. Okay, excuse me. So last one. This one I am going to need to use the big X on because I can't do this in my head. So let's start with this first one, and let's see. Well, 3 times 30 is 90, and the middle term is negative 23. So what are two numbers that multiply to 90, but they add up to negative 23? Well, okay, here's our little factor tree here. Let's see, 15. Okay, well, we have 30 and 3, and that's not going to work. Negative 30. That adds up to negative 33, so that's no good. Let's try negative 20. Does that work? No, that doesn't even go into 90. What am I doing? 4, 5. I think negative 5 probably goes into 90 a bunch of times. That's going to be, yeah, negative 18. Hey, here we go. Okay, so this top one is going to be some kind of, I don't know, 3x, no, getting ahead of myself. We write it as x minus 18 over 3, since 3 is the term in front of x squared. And then we say x minus 5 over 3. 18 over 3 cancels out, and that's 6. So this becomes x minus 6. And 5 over 3 does not cancel out. So we're going to take that 3 and move it in front. So this is your factored polynomial on the top. So we're going to replace that one up there with x minus 6 and 3x minus 5. Okay? Now, I am ready to move on to the bottom one. So let's do this in different colors so we can keep things straight. This is 4 times negative 12 is negative 48. And the middle term is negative 22. So I want two numbers that multiply to negative 48, but they add up to negative 22. So if we take negative 48 over here, and we try to think about, hang on a second, I ignored my own best advice. What did we miss here? There is a greatest common factor that will at least help us a little bit. 4x squared minus 22x minus 12. Well, that's just 2 times 2x squared minus 11x minus 6. That makes this easier. Okay, negative 6 times 2 is negative 12. There's the negative 11. So I drop down my negative 11. Now, I think the numbers that have to go in here are negative 12 and plus 1. Those add to negative 11, but they multiply to negative 12. So this becomes x minus 12 over 2 and x plus 1 over 2, which turns into x minus 6 and 2x plus 1 using our familiar factoring techniques. Don't forget there's a factor of 2 out front. So here we go. 2x minus 6, 2x plus 1, and now you see we can cancel out this common factor right here, and our final answer is 3x minus 5 over 2x plus 1. Okay?